Hello everyone, this is the final part of this series which I have made about the energy curtailed. So previously in the first part I just explained how energy curtailed work and how to calculate the cost of the wasted energy. So if I show you through the program, and in the second part I just try to minimize the curtailed energy and the wasted cost by just considering a reduction factor of 0.5. So right now we are in the final part, and this final part include the optimization algorithm. So as in the previous algorithm or previous process, we just fix our reduction factor with 0.5, and in this series and in this episode, which is the final episode, we just consider the optimization algorithm. So here is the basic code. So if I start from here, we have the load profile and constant generation as we did previously, and this is the cost, and right now we have calculate each and everything. So this is the part where we fix our reduction case, which is 0.5, and that now if you see here, apply reduction factor. So here apply reduction factor, we have to move into the apply reduction factor. So previously we have done with the single file, but in this which is using the optimization algorithm, we have 3 files. So this is the best way to implement a project using MATLAB using functions file, because we have connection of files between each other with the function process, and we can easily monitor what's going on actually. So apply a reduction factor. So we have to now at this point we have to jump into this program. So if I click here and let me click on run button. Okay, and here we are moving into our apply reduction factor, and here is our initial generation, here is our basic load flow, here is our fixed reduction factor, and here is our cost per kilowatt hour. So these data we have to put into this file, and this file will calculate for us, this is the output section, this will calculate us the total wasted energy fixed, and total cost fixed, and total curtailed energy fixed. So next we have to move into this file right over here, and if I click here, so let me click on step, and now we are here into this program. So here we have our initial generation, and this is the reduction factor. So this is the same process which we have done in our last episode. If I click on step, so here you can see adjusted generation profile and adjusted difference, which we have done previously, and calculating the curtailed energy. So if I click on here, so here you can see the total cost which we just sum up our curtailed energy. Right now we have sum up here, so that total cost we will make into our comparison for the optimization algorithm. So we just have total wasted energy, which is 360, total cost, which is 36, and the curtailed energy right over here. So if I click on step, now we are out of this loop. So our using our fixed curtailed energy part, we have just fixed these variables. So now in the next part we have to move into this file, which is which is the reduction factor, optimize using optimization algorithm. So now we are directing into this file, which is optimize reduction factor. Now we have to move into our optimize reduction factor. Here is our initial generation, here is our load profile, initial load profile, cost per hour, and total wasted energy fixed. So this is the total wasted energy fixed. We have considered it here because we have to compare this total wasted energy with the other outcomes which we generate from this function file or algorithm part. So now let me initialize here, and let me click on step. So now I am here. Here we have maximum iterations, you can modify it, and here we have tolerance. So tolerance is actually the acceptable error margin for stopping the optimization process, and here is our learning rate, which is just controls how big of a step we have to take in the direction of the gradient, and gradient is also considered here. Here you can see. So what exactly the gradient? So gradient is the I mean the gradient is calculated here to determine how much the curtailed energy changes when the reduction factor is adjusted. So when our reduction factor, which is previously was 0.5 fixed, this was as the reduction factor will be changes slightly, so our curtailed energy is changes accordingly. So our curtailed energy is changes accordingly. That's how the part of the function of the gradient here. So here is our total wasted energy fixed, which we calculated previously by using the reduction factor of 0.5, and if we want to reduce this amount by the 70%, so that's why we multiply here by 0.7%, 0.7. Our optimization algorithm will tries to reduce the curtailed energy up to 70% by multiplying it with the 0.7. So here is our main loop starts, and here we have to apply the reduction factor. So now we are going into the reduction factor right over here. So let me click here. So this is the first step, and in our first step we are going into into this file, and this file will calculate the cost for us. So here in this file I have initial generation profile and load profile, reduction factor. Initially we have reduction factor of 0.5, which was the same as the fixed, and the cost per hour which is same and constant. So next we have reduction factor, or to compute the gradient, or you can say if we have to take a next step, we have to slightly adjust our reduction factor. So this is the step compute gradient for that calculation. So here we are again, let me click on step. So right now we have let me click on step. Okay, let me now back to that. So now we have exactly same 36, because we are multiplying it with the 0.5 reduction factor. Click on step, and here we have apply again reduction factor, initial generation profile, load profile, reduction factor, again same, and here we have sum up that value which is 0.001. so we are taking a step of 0.001 in 0.5, and we just sum it up, and cost per hour. So let me click on step. So now we have wasted energy of 362. Previously it was different. So that's how it worked, and now we are finding the gradient. So curtailed energy, this one, and minus some curtailed and divided by. So this is a calculation for this. So this is the part of this basic optimization algorithm, and later on we have to ensure reduction factor is within the bounds. This is the criteria of the optimization algorithm. Click on step. Check if curtailed energy is positive and within the target range. So if it within the range, okay, otherwise it will break this. Click on step. Okay, so now this way we have to repeat this process for 1000 iterations. So if I click on for multiple times, let's suppose we are into the 28 iteration. So let me click on step. So right now we have total wasted energy and here. So right now we are here, and our wasted energy is around 0. So that's how this will change the reduction factor, and our main goal in this program was to uh, test, or was to find out the best reduction factor which is suitable to reduce the losses or the curtailed energy. So that's how this program works. And when I click on the run, so here you can see that our reduction factor is considered to be 0.10. Here our curtailed energy is exactly 0, which I think if we put our reduction factor 0.10, then our curtailed energy is exactly 0, which in fixed was 360 kilowatts. So that's how this program works, and here you can see that in form of graph, that this is the basic curtailed energy, and this is the using fixed reduction factor, and using using the optimization algorithm we have 0. And similarly the wasted cost or the cost here is the base case, and here is the second case fixed, and here is the 0. So that's how this program works. I hope you understand the program, and thanks for watching.